This is the third section of the quality of test chapter, and here we look at calculating the size and power of a test. So this chapter's all been about so far what we do with H0. So our choices are that we either accept H0 or we reject H0. Yeah, we either accept the null hypothesis or we reject the null hypothesis. Now, we may accept or reject correctly or incorrectly. So it could be that we accept H0 and H0 is true. That's fine. Yeah, we accept H0, H0 is true. That's not a problem. It could be that we accept H0, but H0 is not true. H0 is false because there's been some sort of change to the mean or the probability. And this is what we call a type 2 error. A type 2 error. And the way that we worked out this type 2 error is it was the probability of accepting H0 given that H0 was false, and we'd have some new probability or some new mean that we would use. Or if we go down the reject H0 route, we could reject H0 and H0 is true. We could reject H0 and H0 is 2. This is a type 1 error. We know how to work these out, this type 1 error. So this is the probability of accept or rejecting H0. I'll just put reject H0, given that H0 is true. Now this is also called the size of a test. So the size of a test is equal to the probability of a type 1 error. So if we work out the probability of a type 1 error, we've worked out what we call the size of a test. Now the last option here is that we reject H0 and H0 is false. Now if we reject H0 and H0 is false, this is called the power of a test. Power of a test when we work out this probability. So this probability would be written as this. It's the probability of rejecting H0 given that H0 is false. Now the bits of this tree diagram that we want to end up on really are either here, accepting when H0 is true, or here, rejecting where H0 is false. These other bits, we want these probabilities to be as low as possible, and we actually want these probabilities here, the power of a test, we want this to be as high as possible. And actually the power of a test is related to the size of a type 2 error. And another way of working out the power of a test is 1 minus the probability of a type 2 error. So 1 minus the probability of a type 2 error. So size equals the probability of a type 1 error, the size of a test. The power of a test is equal to 1 minus the probability of a type 2 error. But it may be easier actually just to work out the probability directly using this, the probability of rejecting H0, given that H0 is false. So this section is all about working out the size and the power of a test. So we can see from this, if we want the power of a test to be high, it means that we want the probability of a type 2 error to be low as we can get it. The random variable x is a normal distribution. Okay, I have a random sample of size 25, so n is 25. On this question, I've been given the null and alternate hypothesis and a 10% level of significance. I want to find the critical region for this test. So x is a binomial distribution with 25 for my sample size and 0.30 as the probability of success. This is going to be one where I use the tables to find the critical region. So it's a lower tail test, since H1 is that the probability is less than or equal to 0. Now, in your formula book or in the textbook, on the textbook will be page 187, I want n is 25, 0.3, and if I go down, it's good practice to do the values either side of 10%. So I'm going to do the one that's just below 10%, and the one that's just above. So just below 10% is when we go down to 4, and less than or equal to 4 is a probability, make sure I write down the right number here, of 0.0905. And the probability when we go down to 5, less than or equal to 5, is the next one down, which is 0.1935. Okay, so this one is less than 10%, this one is greater than 10%, so my critical region is going to be when what I observe is less than or equal to 4. That's my critical region. Right, part B, find the size of this test. Now, the size of a test is equal to the probability of a type 1 error. You don't necessarily need to write all of this down when you're doing an exam question. It's just to show you how this all links together, which is the probability of rejecting H0 when H0 is true. This is equal, remember, to the actual significance level. And I get that straight from the table, and actually I've already written that down. The actual significance level is this 9.05%. So let's write that down, 0.0905. So that's the size of the test, the actual significance level, probability of a type 1 error. Okay, part C. It now says, given that the probability has changed to 0.2, calculate the power of this test. Now, the power of a test, this is 1 minus the probability of a type 2 error, or you can say actually this is the probability of rejecting H0 when H0 is false. So probability of rejecting H0 when H0 is false. So rather than do 1 minus the probability of a type 2 error, we can do it this way. It's probably a little bit quicker, since that is the probability of us rejecting H0, which will happen when x is less than 4, given that the probability is now 0.2 or 0.20. So this is fairly straightforward to work out now. So now we've got a binomial distribution, still the same sample size, but our probability is now 0.2, and we want to work out the probability that x is less than or equal to 4. It's as simple as that. So using binomial CD, we type in x as 4, n 25, p is 0.2, and we'll get 0.42067443, shorten that to 4 decimal places, 0.4207. So there we go. So let me just highlight those answers before we move on. We've got a critical region. We worked out the size of the test, which was the probability of a type 1 error, rejecting H0 when H0 is true. We then worked out the power of the test by working out the probability of rejecting H0 when H0 is false. So you can see the link between these two things, the size and the power. Both are linked to the probability of rejecting H0, either when we've made the right decision when H0 is false, or the wrong decision because H0 is true. Okay, so we've got jam which is sold in jars. The amount of jam in grams is normally distributed. We have a mean here of mu and a standard deviation of 5. The manufacturer claims that the mean is 106, and quality control officers will take action against the manufacturer if the mean is less than 106. A random sample of 30 jars is examined and a 5% level of significance is used. Part A, find the critical region for the sample mean using this test. Okay, so we start with H0 and H1. So H0 is going to be that the mean is 106. H1 is going to be that the mean is less than 106. Let's define our random variable, which is the mean amount of jam in 25 jars. The mean amount of jam in 30 jars. Not sure where I got the 25 from. So our sample mean we know is normally distributed with a mean, a population mean of 106 and a standard deviation of 5 squared over, not the square root of the sample size, but the of over 30. Like this. I'm going to draw a little diagram like this for my normal distribution. Often find this helpful. Like this, where I have my mean here of 106. I have my standard deviation, and that will be 5 over root 30. And it's a lower tail test because I've got less than here, and the area is going to be 5%, and I want to find a critical value. So this is the critical value here that I want to find. So to do that, I'm going to use inverse normal, and with inverse normal we type in the area, and the area is going to be 5%. We type in the standard deviation, which is going to be 5 divided by root 30, which when you type it in becomes 0.9128. Then the mean is 106. So that gives us 104.9854 decimal places. Because I want to give my probabilities the 4 decimal places, I really want to give any numbers that I work with in the calculation to at least 4 decimal places. Okay, so that's the critical value. Part B, it says given that the mean is actually now 102, find the power of this test. Now the power of a test, is when, or it's the probability of rejecting H0 given that H0 is false. Now I would reject H0 when my sample mean drops below 104.4985, given that H0 is false, which means actually the mean is 102. So I'm going to draw a little diagram for this one so we can see what's going on. Now this time the mean is 102. The standard deviation remains unchanged, 5 over root 30. And I want to work out the probability that x is, or the sample mean, let's put that in, falls below this 104.4985 figure. So I actually need to work out this area here, which I can do using normal CD. So yeah, on normal CD we would type in a lower value, anything small, so I've done 0, an upper value, now that's this 104.4985, or you can use the answer button if you've just calculated part A. The standard deviation is going to be the 5 divided by root 30, and the mean, now we need to change it to 102. So if we do that to 4 decimal places, I'll get 0.996899599, because there's loads of 9s here, so 0.9969 to 4 decimal places. So that's the power of the test, nice and high. That's what we want. Okay, a particular mobile phone provider fails to deliver text messages with a probability of P. Brooke wants to investigate whether the probability of these failed text messages is greater than 2%. So we're given H0, we're given H1, so it's going to be a one-tailed test, and Brooke notes the number of text messages she is able to send successfully up until the first failure. So when we get failure, she stops. So this is telling me a geometric distribution. Yeah, always look out for clues that tell you the type of distribution. If this value is less than or equal to 5, she rejects H0. If it is more than 100, she accepts H0. If it is more than 5 but less than equal to 100, she notes the number of additional text messages. So if it's between those values, she notes the number of additional text messages she's able to send successfully up until the next failure. She rejects H0 if this is less than or equal to 5 and accepts it otherwise. Find the power of this test. Now, probably the best way to tackle this question is to read through it and maybe convert it to some sort of tree diagram so we can sort of visualize what's going on. So we've got, it's all about H0. So it says that she will accept H0 if the number of text messages or the number of messages is more than 100. So if it's more than 100, we will accept H0. And if it's less than or equal to 5, let's call this X. It tells us that she will reject H0. But there is another way she's going to reject H0. It says that if actually the observed value X is greater than 5 and less than or equal to 100, so if X is greater than 5 and less than or equal to 100, basically every value in between, then it says that she takes note, and if she notes that X is still less than or equal to 5, then she will reject H0. And then otherwise, so if anything else happens other than X being less than or equal to 5, which basically means that X is going to be greater than 5, we're told that she will accept H0. Yeah, so a little diagram like that might just help us in dealing with this question, otherwise it can become quite confusing. Now, part A asks us to find the size of this test. Now remember, the size of the test is equal to the probability of a type 1 error. And the probability of a type 1 error is the probability of rejecting H0 given that H0 is true. So what we need to do is to work out what's the probability of rejecting H0. Now, when do we reject H0 in this question? Well, it gets rejected up here, or it gets rejected here. Okay, so let's write that down. We, in the right colour, we reject H0 if the probability of X is less than or equal to 5, okay, that's this bit up here, or the probability of X is between 5 and 100, so or the probability of X is greater than 5, less than or equal to 100, and okay, there's this bound here, bit here, X, the probability of X is less than 5. Now, we know in questions like this, where the probabilities are independent, that if we have or, we replace it with a plus sign. If we have and, we replace it with a times sign. Now, since this is a geometric distribution question, just a reminder, if we need to work out the probability that X is less than or equal to X or N, it's 1 minus the probability, 1 minus the probability to the power X. So this is going to help us work this out. and in this question P is going to be 0.02. So we're working out the probability of rejecting H0 given that H0 is true, which means that the probability is going to be 0.02. So let's work this out. So I'm going to do this bit first. So the probability that x is less than or equal to 5 is going to be, let's do that over here, 1 minus p, which is 0.02 to the power of 5. Okay, so that's that bit. Plus, we need to work out this bit here. Okay, and we'll do that here. Now, if I want to work out the probability between values, I actually need to work out the probability. Let's write it down here. I'm going to work out the probability of x up to 100 and subtract the probability. Now, if it's greater than 5, I need to subtract the probabilities up to 5. So this is what I'm going to be doing next in the next bracket. So the probability up to 100 is going to be 1 minus p to the power 100 minus, so I need another set of brackets here so that minus doesn't get messed up, minus, and this will be 1 minus p to the power 5. Okay, times by, now this part here. Okay, and I will do that here. So I'm going to take this away because we don't really need that anymore. Should know the formula. Maybe I'll put the formula somewhere else. Yeah, so times by the probability that x is less than or equal to 5, which is the same as this again. So 1 minus 0.02 to the power 5. So we're going to work all of that out on our calculator, being very careful with brackets and the like, which means I need to add another bracket here. And if I'm going to add another bracket there, whoops, I need to make sure that I don't rub out too much. So that 5 should be there, and I want another bracket here. And let me put the cloud back. Clouds are very important. Like this. Yeah, so let's see what we get. Right, so I get 0.170185. So if it's 018, it'll be 02 to 4 decimal places. So if we're not careful, this could be a very complicated question. But by drawing a diagram so you can physically see what's going on and when she's going to reject H0, that will help us in terms of the working. So you might want to pause it and just sort of go for it yourself. Now part B, calculate the power of this test when P is 0.015. So remember, the power of a test is the 1 minus the probability of a type 1 error. Sorry, a type 2 error, but we've not calculated a type 2 error. So it's the probability of when we reject H0, given that H0 is false. Now in this case, the reason it's false is because the probability is actually 0.015. So all we need to do is to change the probabilities here to 0.015. So we can use exactly the same working. All that's changed is the probability. So I'll write out the calculation, but on your calculator what you might do is just scroll back and change these to 0.015. So let's do that. So it's going to be 1 minus 0.015 to the power 5 plus 1 minus 0.015 to the power 100. So it's exactly the same working as before. Minus, yeah, I need extra brackets here. 1 minus 0.015 to the power 5 times by 1 minus 0.015 to the power 5. Now if on your calculator instead of typing this in you just typed in 0.98, then you can just go back and change it to 0.985. So you can just go after the 0.98 and just stick a 5 at the end of each one of those to get the answer. So if we do that and work this out, I've worked out already, we get 0.124 and then it's 2128696. So that'll be to 4 decimal places 1242. So this is the value of the power of the test, which we'll just highlight. So you should now be able to do exercise 8C on pages 161 to 162. So just as a quick recap, we worked out the size of a test, and the size of a test is equal to the probability of a type 1 error, and a type 1 error, that's the probability when we reject H0 and it's true, H0 is true, whereas the power of a test, well, that's equal to 1 minus the probability of a type 2 error. And actually the power of a test is the probability that we reject H0 and H0 is false. So this little flowchart may help you.